Hi everyone, and this is Sandeep. You are watching Samyans Academy, and in this session, we are going to discuss about the motion from the class 9 chapter. So let us start. So describing the motion. So what is a motion? Motion is a change in position of a body with time, and motion can be described in terms of the distance moved or the displacement. Okay. If my position is not changing with respect to time, it is said to be rest. If my position is changing with respect to time and with respect to observer, then we can say that object is in motion. Okay. So next one, and here we have the distance is there, displacement is there. So what is the distance? The distance means the actual length of the path traveled by the body is called as distance, and the displacement is length of the shortest path traveled by a body from its initial position to its final position. Ante? So distance move is actual path covered by the body we called as a distance. The short path between the initial to final point is called as displacement. Okay, here we have one example. So if your body starts moving in a straight line from the origin O, moves through the C and B and reaches to the A, and then moves back to the reaches C through the B. Now you see, one body starts from the O, okay, and it reaches to the B through the C, and finally it reaches to the A. Means from O to A, how many kilometers are there here? Yes, 60 how many kilometers are there? 60 kilometers are there. Again it come back to the C, so 62, again it will come back to the next one. So how much distance it is? So from here to here, how much distance? 60 to 25 means it is around 60 minus 25 is how much it is showing. This much is how much here? This is how much here? 35 kilometers. Okay, and the object come back to the 35 kilometers. Now how much distance traveled, the total distance traveled by the object is how much now? So O to A is the 60, again it come back to the C up to 35 kilometers, means 60 plus 35 is how much? Total 95 kilometers. So in this case the distance is a 35 kilometer, but the displacement means you have to see your initial position O here and final position is C. So and you have to see the shortest path between initial and final, how much it is? 0 to C is, oh sorry, O to C is how much length is there? 25 kilometer is there. So in this case the displacement is 25 kilometer and the distance is 95 kilometer. Is it clear everyone? So move on to the next. So now we have your uniform motion, non-uniform motion. Okay, if a body travels equal distances in equal intervals of time, it is said to be uniform motion. Means suppose you are moving with constant speed, so your vehicle is moving with 30 kilometer per hour, means so what it will show. So if your vehicle is moving with 30 kilometer per hour, so let us say, so your vehicle is moving 30 kilometer per hour, so what it will show? 30 kilometer per hour indicates what? So you are maintaining constant speed for 1 hour. You are moving how much distance? 30 kilometer. For next hour also you are moving 30 kilometer. For every hour you are moving the same distance, then it is said to be uniform motion. It means in equal interval of time, if body is said to be, if body is moving in the equal distance, so it is said to be uniform motion. Now non-uniform motion means if a body travels unequal distances in equal interval of time, or it is said to be non-uniform motion. Means, so if suppose in 1 hour you have moved with 30 kilometers, next hour you change your speed, means every hour you are changing the speed, means so it indicates that non-uniform speed. Okay, so if a body travels unequal distances in equal interval of time, it is said to be non-uniform motion. So what is uniform motion? If a body, when will you say this? A body is traveling the uniform motion if body travels equal distances in equal intervals of time. If both are equal, then it is said to be uniform motion. If a body travels unequal distances in equal intervals of time or equal distances in unequal intervals of time, so it is said to be non-uniform motion. Okay, then come to the speed. So what is speed here? Speed equal to distance by time. So speed equal to here, what is the speed? So speed equal to distance by time. So distance traveled by a body in unit time we called as speed. In a unit time we called as speed. If a body travels a distance s in the time t, so it is said to be v. So v indicates speed, so s by t here, distance by time. Okay, then SI unit of speed. Okay, so what is the SI unit of speed? SI unit of speed is meter per second or CGS unit. Smaller units are centimeter per second. Then what is average speed? So average speed is a ratio of the total distance traveled to the total time taken is called as average speed. So total distance traveled by total time we called as average speed. Okay, is a, so what is average speed? So average speed is a ratio of the total distance traveled to the total time taken we called as average speed. So average speed equal to, so you have to write like this. Average speed means average speed equal to total distance traveled by total time taken. Okay, total distance traveled by total time taken. So this is called as average speed. Total time taken, sorry. So what is this? Total time taken. Okay, this is called as average speed. You see everyone, the rate of motion of a body is more meaningful if we specify its direction, motion along with the speed. So what is the velocity of the body? So it is the displacement of the body per unit time, we called as velocity. And how will you define the speed? Speed equal to distance by time, velocity equal to displacement by time. So what is average velocity? Average velocity means total displacement by total time taken is called as average velocity. Okay, now how will you calculate the average velocity? If you know the initial velocity and final velocity, initial velocity plus final velocity by 2 also will give the average velocity. So v equal to u plus v by 2 also will give the average velocity. Okay, so next one we have the rate of change of velocity. Rate of change of velocity means, so your speed is increasing gradually, means your speed is increasing gradually with respect to time. Your speed is moving uniformly, means your speed is increasing uniformly with respect to time. But every certain intervals your speed is also increasing a certain value. Means for example, if you take the 10 meter per second, you take the speed. Okay, so let us assume that your in first second your speed is 10 meter per second. Okay, in the first second, after 5 seconds your speed will become 20 meter per second. Next to 5 seconds, for every 5 seconds your speed is increasing constantly, means the next to 5 seconds your speed is increasing 30 meter per second, but your speed is increasing constantly in particular interval of time. So it is said to be acceleration, means your speed is increasing, right? In particular interval of time in your speed is increasing, so it is said to be acceleration. So acceleration is nothing but it's a change in the velocity by time is called as acceleration. So here accelerations we have the two types: uniform acceleration, non-uniform acceleration. So if you are increasing your speed with respect to the time, means if you are increasing your speed in equal interval of time, equal amounts, that is said to be uniform acceleration. So if the change in the velocity is equal in the equal interval of time, it is said to be uniform velocity. So when we will say it is non-uniform velocity, if the change in velocity is unequal in equal interval of time, it is said to be non-uniform. It means your speed is varying every time with respect to time. So it is said to be non-uniform acceleration. But your speed is constantly increasing with respect to time, it is said to be uniform acceleration. So next one is graphical representation of motion. Then how do you take this graphical representation of motion? Let us see now. So in this, what you have to do here, so you have to plot the graph between the x-axis, so y-axis versus x-axis. On x-axis you have to take the distance, on y-axis you have to take the time. Now you see, on x-axis what we are taking here, on x-axis we are taking distance, on x-axis, sorry, on y-axis we are taking here distance. So take here distance and you take here time. Okay, for example, so if you want to plot the uniform graph, means uniform motion, so how it will be look like? So let us say time. So every so 0 seconds we have at 0 meter. After 5 seconds the body moves up to 5 meter. After 10 seconds, means at 10 seconds the body moves to 10 meters, like that. If equal interval of time, if body is moving in the equal distances, so it is said to be uniform motion. The next to 15 seconds the body is at a 15 meter. Okay, like that. The next to 5 seconds the body is at a 20 meter. Okay, so for these values if you make the graph, then how it will look like? Now you see, so I am taking here 0. Let us say this is the 5 seconds and this is 10 seconds and this is 20 seconds, and each 5 seconds the body is moving to the 5 meters. So at first 0 seconds the body is at 5. Okay, so now it is 5. So at 10 seconds our body is at 10 meter distance, means here it will come. At 20 seconds our body is at a 20-meter distance. Okay, when you plot the graph for this, you will get like this. The straight line which is passing through the origin, you will get like this. Okay, and this is the line which is passing through the all these points. Okay, and it will indicate the uniform motion. Then how do you know that it is uniform motion or not? So you just check this with equal interval of time. If body is moving equally, so it is said to be uniform motion. Is it clear? So this is a graph which is having the constant to slow. Okay, and which will indicates the uniform motion. Okay, so one more graph. Suppose your position is not changing with respect to time. For example, if you take this graph like this, so on x-axis you take the second time, on y-axis you take the distance. Okay, so when you make the plot like this, suppose for example, if body is not moving with respect to time, so you take the distance here. On y-axis you take the distance, on x-axis you take the time. Okay, means our body is at here at 5 meter distance, means at every seconds. Now you see at 0 meter, at 0 second also, so starting point, your body is at 5 meter position, means after 5 seconds also there is no change in the position, your body is still staying at 5 meter only. After 10 meter, after 10 seconds also it is showing the same position. After 20 seconds also it is showing the same position. Means if object is not moving with respect to time, so it is said to be object is at rest. Okay, so how will you plot the graph for the rest? So when you join all these points, so the line which is parallel to the x-axis, this shows that object is not moving but time is moving. With respect to time, object is not moving but time is moving, so it is said to be object is at a rest. In the previous graph, in each time of interval, so the object also moving its position. Okay, if position is changing with respect to time, it is said to be object is moving. But how it is moving? In equal time of interval, and object is covers equal distances, so it is said to be uniform motion. Is it clear? And one more thing is there, so non-uniform motion. So non-uniform motion, how will you represent the non-uniform motion? So you see here, if object is constantly changing its position, means if object covers the distances in unequal distances in equal intervals of time, it is said to be non-uniform motion. For example, you take some values here. Let us say at 0 second our object is at 0 meter. Okay, after 5 seconds it moves up to 5 meters. Okay, after 10 seconds it moves up to 12 meter, let us say. And after 5 seconds or next to 5 seconds, next to 15 seconds, let us assume that, so it is moving up to 24 meters. Like that, when you plot the graph, now you see how that plot will look like now. So you, on the x-axis you take the time, on the y-axis you take the distance mode. Okay, so now you see we have taken here 0 second. At 0 second our body is at 0 meter. After 5 seconds, then what, where is our body now? At 5 meter only. So this is a 5 meter. Okay, let us say this is 10 meter, and this is 20 meter, and this is the 30 meter. Now you plot the graph. Okay, at 5 seconds our body is at 5 meter, means you put the dot here. Next, after 10 seconds, after next to 5 seconds, where is our body now? After the next 5 seconds, means at 10 seconds, our object is at 12 meters. So 12 meter means around here it will come, right? So here it will come 12 meters. Next one, after 15 seconds, our object is at 24 meters. So 24 meter, around here it will come, right? So here it will come. Now you see sometime it is moving, it is not exactly showing the straight line, it is not exactly showing the straight line, and it is showing the curved line. So I want to take one more value. For example, so when you move after 5 seconds, let us say now you moved up to how much distance here? 35 meter. Let us say this is 35 meter. 35 meter means you have to take one more value of, so this is 35 meter. Next to 5 seconds, after next to 5 seconds means at 20 seconds, then object is at 35 meters. Okay, so when you make this graph like this, it is showing the one curved line. Okay, this plot is showing the curved line, means can you say it is uniform motion? No, sometimes it is showing straight line path, sometimes you are showing curved line path, sometimes it is showing this curve bends towards the y-axis, means distance axis. If curve bends towards the time axis, it is said to be object, the motion of the, means speed of the object is reduced. Okay, when will you say the speed of the object is reduced? When will you say, if this curve bends towards the time axis, in that case object, the speed of the object is slowing down, means object is, its object reduced its speed. Means if curve is bending towards the y-axis, so it is showing that the speed of the object is increasing. Speed of the object is increasing. Okay, if curve bends towards the time axis, speed of the object is decreasing. If curve bends towards the distance axis, it indicates speed of the object increasing. So sometimes the speed is increasing, sometimes the speed is decreasing, and like this motion we called as non-uniform motion. Okay, so now we come to here. Now in this graphical representation, we have taken here the change in the position of a body with time can be represented on the distance time axis. In this graph, distance is taken on the y-axis. Now you see, distance we have taken on the y-axis and time is taken on the x-axis. The distance time graph for the uniform speed is a straight line. So this indicates the uniform speed. Okay, if you get the straight line like this, so it indicates uniform speed. And we can determine the speed of the body by using these values. Suppose how will you calculate the speed? By using the graph. Now you see here we have taken the 5 seconds and 10 seconds. At 5 seconds our object is at 10-meter distance. After 10, after next to 5 seconds our object is at a 20-meter distance. So suppose you take the value between 5 to 10 seconds. Now from this you can plot the, now you from this you can calculate the speed of the graph or the speed of the object. So speed equal to distance by time. Okay, distance is how much here? Distance is how much? Just a minute. Okay, so distance is how much here? Now you see, distance is so at t1 the position of the object is 10-meter. At t2 the position of object is 20. The distance moved out by object is how much? 20 minus 10 is 10-meter. So what is the time interval we have taken? In between 5 to 10 seconds. 5 to 10 seconds means the time is 5 seconds. Okay, within the 5 seconds the object moved up to how much distance? 10-meter distance. So 10 by 5 indicates, so distance by time indicates speed. So okay, so in this way you can calculate the speed. Okay, then slope of the distance time graph will give the speed. Always remember, slope of distance time graph will give the speed. Slope means change in y-axis by change in x-axis. Change in y-axis means it will give the distance, by change in the x-axis it will give the time. Okay, slope of the distance time graph will give the speed. Is it clear everyone? Okay, now move on to the next one. So in this way we can calculate the distance moved by the object. Now you see, and this is the graph, it indicates uniform motion. Have you observed, and this curve bends towards the uh, distance axis. Okay, within the short time of interval it covers more distance, means it indicates non-uniform motion but speed is increasing. Okay, now here you see the, so here we have plotted the graph between the velocity and time. Okay, then how do you plot the velocity time graph? Let us see now. So these graphs are very important for your MCQ questions. Everyone please look at here. So if you plot the graph between velocity versus time, then suppose if object is moving with constant speed, it indicates uniform motion. If indicates uniform motion, okay. Now you see, so at 5 seconds, at 10 seconds, at 20 seconds, at that, sorry, every 5 seconds you take, and this is 15 seconds. Okay, this is 15 seconds, and this is 20 seconds. So time we are taking in seconds. Okay, and speed you take here meter per second. Suppose our object is moving with 10 meter per second. Let us say this is 5 and this is 10 and this is 15. Okay, every time you see here, if object is moving with constant speed, so we have taken the plot between the velocity versus time. Okay, velocity versus time or speed versus time. Let us say I am plotting the graph for the uniform speed. So for uniform speed you have to take the constant values, means that your speed is not changing, your speed is always constant with respect to time. Suppose let us say your speed is 10 meter per second. Okay, so at 0 seconds from observing point, so you have to say we have observed from the 0 seconds, at that time your vehicle is moving with 10 meter per second. Let us assume that after 5 seconds also your vehicle speed is not changing, it is showing the same value. After 10 seconds also, after 15 seconds also it is showing the same value, after 20 seconds also it is showing the same value. Means every time it is showing the same value, means your object is moving with constant speed. Okay, on the y-axis we have taken now speed, previously we have taken the distance. Okay, so if distance versus time graph, if distance is not moving with constant time, means if distance is same with respect to time, so what it will indicates, this graph indicates rest, but here this graph indicates uniform motion. So what it will indicates, uniform motion. So this graph indicates uniform motion. So if this line is parallel to x-axis, so we have plotted the graph between the speed versus the time. If you see like this graph, means it indicates uniform speed. Suppose if you plotted the graph like this, for example, you see here, if you got this graph like this, what it will indicate, what it will indicate, can you guess? Means is every equal interval of time, your speed also increasing equally. So what it will indicate? Can you guess what it will indicate? Yes, no, you are wrong. Uniform motion wrong, uniform speed is wrong. Why? Because this is not uniform. Your speed is increasing. Your speed value is changing. So what it will indicate? This indicates uniform acceleration. Okay. So if you plot the graph versus speed versus time, so it is not indicating the uniform speed. Why? Because for uniform speed, speed is constant. Okay, but here speed is changing 5, 10, 15. For equal interval of time, the speed also increasing equally. So this graph indicates uniform acceleration. Remember, so when you plot the graph versus velocity versus time, just you observe here, your velocity is constantly increasing with respect to time. Okay, so in equal interval of time, your speed also increasing equally. So this type of graph indicates uniform acceleration. So you have to write here an option. You have to write here, this graph indicates uniform acceleration, means your speed is increasing constantly. So this is a straight line. Suppose instead of straight line, suppose if you are getting like this, for example you are getting like this, if you are getting like this, or if you are getting like this, the curve bends towards the time axis, or it curve bends towards the velocity axis, means this, so within the short interval the speed of the vehicle increases, means it is suddenly increasing, speed suddenly increasing. Okay, so suppose for example if graph indicates like this, if it is like this, okay, means within the short time of interval the speed is not increasing here, the speed is not increasing. Okay, and this is also, here speed is varying. Can you say is it uniform acceleration? No, it is not a uniform acceleration. Okay, it is non-uniform acceleration. It's a non-uniform acceleration. Sometimes speed is increasing, sometimes it is decreasing. Okay, this is a non-uniform acceleration. Okay, previously we plotted the graph right like this. So what it will indicate? So this graph indicates uniform acceleration. Remember all these things. Now you see one more thing is that the graph under this plot, when you, so this under the area of this graph, so what it will indicates, this area, what it will indicates, the area covered between the area covered under the velocity time graph. So what it will indicate, it indicates, what it will indicate, can you guess? That is distance. Already you know that area equal to so distance. How will you calculate distance? Equal to area under velocity time graph gives distance. Remember this, it's a very important. To find the distance you have to take the considered area. Now this area is look like it's a triangle. Okay, can you calculate the area of means distance covered by this object is how much? Can you cover, can you find out the answer? Area under the velocity time graph, and this area is look like as a triangle, right? So how will you calculate this? Half into base into height, half into base into height. So what is the base we have here? 15. Here how much? What is the value up to here? This is 15. Half into 15, and that here speed also 15. 15 into 15, 225 by 2. 2 how many times? 1 1, and yes, 112.5 meters. Then object covers how much distance within the 15 seconds. Okay, that is how much here? 112.5 meters. Everyone, please remember this. Area under velocity time graph give you distance. Clear? So come to the point here. Now you see, in this graph, we have taken the velocity on the y-axis and time on the x-axis. Okay. So when you make the graph like this graph is showing the straight line which is parallel to the x-axis. And what it will show, after 5 seconds also your velocity is here only 20. After next 5 seconds also your velocity is not moving. Okay. After next 5 seconds also your velocity is not moving. Means your velocity is constant every time. So this graph indicates uniform motion. The area under this graph give you distance. Okay, remember this. So next one is, suppose if your velocity is increasing in equal time of interval, your velocity also increasing equally. So this graph indicates uniform acceleration. Means your speed is increasing constantly with respect to time. So this graph indicates uniform acceleration. This area under this graph indicates distance traveled by the body. Okay, just now we discussed all these things. Now you see, in this graph velocity is decreasing with respect to time. So when time is moving, the speed is reducing here, velocity is decreasing. But how it is decreasing? Uniformly decreasing. So it indicates uniform retardation. So this graph indicates what here? Uniform retardation. Why we are calling uniform retardation? Now initially the speed was how much here? 30 meter per second. After 20 seconds the speed is slowly reducing, so it is coming down like this. So it is gradually decreasing. Okay, constantly reducing. So it is a constant slope. So it indicates uniform retardation. Okay. Now here you see this graph. Sometimes the speed is increasing, sometimes it is decreasing, increasing, decreasing. Okay. So this is we called as non-uniform velocity. Okay, non-uniform velocity. Next one is, yeah, here we have the three equations of motion. What are the three equation of motion we have here? V equal to u plus at, s equal to ut plus of at square, v square minus u square equal to 2as. Okay. Now remember, so what is u here? U indicates initial velocity, v indicates final velocity, a indicates acceleration, and what is the t here? T is the time and s is the distance traveled. Okay. So based on these equations we have some problems. So afterwards we will do these problems also. Next one, here we have equation of velocity relation. So this is not in your syllabus now. So you remember v equal to u plus at formula, and this is a formula of s equal to ut plus of at square. So it's s means distance, u is initial velocity, t is the time. Okay, a is the acceleration. Okay, now here this graph indicates v square. This is indicates the derivation of v square minus u square equal to 2as. Now in the next topic we have your circular motion. Circular motion means the motion of a body in the circular path is called as circular motion. If any object which moves in the circular path, so it indicates circular motion. When object is rotating circular path is constant speed means, listen everyone, look at here. So now this particle is moving on a circular path. Can you say is it constant speed or constant velocity? Can you say it is moving? So speed is not changing. Suppose you are moving in circular path. So if you are moving with your car in circular path, your car speed is not changing. But your speedometer is showing the same value. So then what it will indicate? But your car is rotating on the circular path. Then what it will indicate? So is it moving with constant speed or is it moving with constant velocity? Yes, velocity is not constant. Velocity depends on direction. Here direction is changing every time. Direction is changing, but your only magnitude of the speed, that value is not changing. In speedometer it is showing the same value. So in this case you have to show that, you have to tell that the object is moving with constant speed but not constant velocity. Then how do you say it is not moving with the constant velocity? So in the case of velocity you have to consider direction. If direction is not constant, now you see every time you see the direction of the object is every time it is changing. When object is coming here, the direction is here. When object is coming here, the direction is here. If object is going this direction, if direction is here. If every time the direction is changing, particle direction is changing. If particle is direction is changing, so it is said to be it's not a uniform velocity, but it is moving with uniform speed. Okay, so it is moving with uniform speed, but it is not moving with uniform velocity. So why it is not moving with uniform velocity ante em cheptaru? Yes, how will you say that how it is not moving with uniform velocity means? So in the case of velocity you have to consider direction. your direction is changing every time. Okay, so this is your chapter motion. So in this chapter we have some in-text question and exercise questions, and we will go through that. Okay.